Okay, welcome back sa current continuation sa ato ang topic on electric potential. So given this problem, particularly on problem A, this is similar, this actually the same problem that we solved, wherein we calculated for the electric field by using directly the Coulomb's law, and it's kind of challenging and cumbersome if we use this style because it involves direction, because this is a vector quantity, so we have to keep track of the direction of the field and so on. Whereas if we calculate first the potential, it would be a lot easier going to the electric field, because when we manipulate the electric potential, it is easier for us because scalar man na siya. It's a scalar quantity, and dealing with scalar quantity is easier and straightforward to compared to dealing with a vector function or entity such as the electric field. So having this scalar potential, if we successfully derive this one, then we can extract the electric field based on this equation. Okay, let's try to calculate the electric field for the potential first, given this problem. So technically we have charge Q on the opposite end, which is, this is the origin, this is the x-axis, and then this is the z-axis, and we want to find the electric field at point P. But in our case, for easier calculation, we will calculate first the potential at this point. So potential, what is the potential at that point? Okay, so this is overall, this is distance d, and therefore this is d over 2, this is d over 2. Now to calculate for the potential, we recall the formula for potential, which is 1 over 4 pi epsilon naught charge Q, since discrete man is siya, so just use this formula, Q over, it's actually Qi, so summation is siya, I from 1 up to 2, and then R. Okay, so expanding this one, we get 1 over 4 pi epsilon naught Q1 over R1 plus Q2 over R2. By the way, Q1 and Q2 are both Q, so pwede to siya i-erase na siya diha. So it's just Q ra na siya. Okay, so this is just Q. Okay, now this is R1. Not good, ani. So dili kay siya straight, but anyway, let's assuming lang straight line na siya. So this is R1 and this is R2. Now R1 and R2 are distance, no, from the source point to the point in question, which is point P. We can use Pythagorean theorem to get the R1 and R2 by having this relationship between them. We have the z, and this is d over 2. So therefore, we have 1 over 4 pi epsilon naught, and then have, I think, mausa ra siya because the same naman sila. R2 and R1 kay equal sila. Therefore, it's just the square root of 1 over 4 d squared plus c squared, right? Using Pythagorean theorem. So it's, we have now the potential, and then from the potential, we can extract the electric field at this point by using or invoking this formula, negative del V, right? Negative del V. So we can just say, since the potential is just in terms of z as a function of z only, and this is Cartesian coordinates, by the way, so we just have to take the derivative of this whole entity, the scalar function, with respect to z. So we have 1 over 2 pi epsilon naught. Cancel ang kaning 2 sa 2q and sa 4 sa ubos. So we have q over square root man na siya, no? So we have d squared over 4 plus z squared to the 1/2. Okay, that would be good. And then, taking the derivative of that, we get 1 over 2 pi epsilon naught. So this is q, magawas naman na siya. And then, it's, ano naman, itong isulat na lang. So we have d squared over 4 plus z squared to the 1/2 q over 2 pi epsilon naught. We have 1/2, and we have d squared over 4 plus z squared. This is negative 1/2. Okay, ako man siyang gisaka, right? So this is negative 3/2. And then derivative of the inside of this open and close parenthesis, or kaning quantity, we have 2z. Therefore, cancel ang 2z sa 1/2 sa ubos. We still have 1 over 4 pi epsilon naught q over 1/4 d squared plus z squared to the 3/2. And then the direction of the electric field, of course, because this is a vector quantity, so this is sa z nga direction, so we have k hat. So this is now the electric field. So take note, this is the same electric field that we calculated in our previous example, wherein we directly solve the electric field for this system using the Coulomb's law, Coulomb's equation. But during this kanina moment ka when nag-solve that, we arrive at still the same equation, but nag-detour ta using the potential first, calculating the potential first before calculating the electric field, because in doing that, it would make our calculation a lot easier because we are dealing with a scalar quantity or a scalar function compared to dealing directly, attacking head-on the vector function. Okay, so that would be the solution. So for letter B, you can practice this at your own convenient time at home. How do you get now, for this case, nga instead of having positive Q here, it is done siya of negative Q, right? Mahimo na siyang negative diha. So what could be the electric field? Imo siya i-check man sa katong previous calculation na to. It should be the same. This time, you calculate first the potential and then calculate the electric field afterwards. We will try to solve this one, letter C, this one. So, nakasolve na putani before, right? But we just have to compare. This time, we'll compute first the potential. Let's calculate that one. So we have our system here. So this is a disk. Assuming lang nasa center na siya. So what will be the potential at point P? Then this is R. And then this is ang imong disk na siya charge density or surface charge as sigma. So to calculate for the potential, we have to, this is R na siya nga distance there. So potential, since ay mong source distribution is, di naman siya discrete, it's a continuous charge distribution. We'll be using the formula for a surface charge distribution. 1 over 4 pi epsilon naught right? Then we have dq over r, where dq is just this one. We have it's just sigma dA. Wala naman na siya, diba? So, where dA is just a small change in your area, or mo siya i-integrate, we have dA. So, it's just an area of a disk, right? Ang area sa imong circle, or yeah, it's an area sa imong disk. So we have 2 pi r dr. Okay, so this is in terms sa dq man siya. So small change sa dq is actually a small change po sa imong r component. Ang imong theta is para imong phi sa ning angle diri is actually constant. What actually mag-change is ang imong sigma or charge density is dependent siya sa r. We have this one, dependent siya sa r. So we have sigma 2 pi r dr. Now we can solve for the potential. So we have 1 over 4 pi epsilon naught integral, and we have sigma 2 pi r dr over, so ang unsa ni siya nga distance din ha. So this is actually this is z, by the way, sorry for that. This is r. Okay, so the distance is just particular gihapon, we have r squared plus z squared, right? 1/2. So having to integrate this one, so ato sa i-simplify, mag-cancel ang 2 pi, and we have 1 over 2 epsilon naught. So sa gawas ang sigma, so we have 2 epsilon naught. Then we are left with r dr, this one, r squared plus z squared. So there are a lot of ways, or it could be various ways to integrate this one. You can review your calculus kung saan siya pag-integrate. You can actually let u siya, then you have your du. So pwede ka gamit ana nga style. Basta kay ang result niya, you check this one sa inyong paper, you calculate it. So that integral, if you evaluate that one, by the way, ang iyahang limit, because r man siya, let's say ang imong radius ani is big R. So from 0 to big R. So we have square root of r squared plus z squared minus z. So that would be the potential for this system. So we will not stop there once you get the potential, because we are asked to find the electric field. So we can get the electric field immediately by invoking this formula. So kana siya, derivative naman siya. Okay, so taking the derivative of that, okay, we have z so we substitute we substitute the expression for the potential, to epsilon naught square root of r squared plus z squared minus z, right? So if you take the derivative of that, then you simplify, you get this expression. Should be able to get this. Okay. So that is the electric field for this problem. So we have this one. So for this problem, um, as I said kanina, kamo na lay solve sa kaninga problem bitaw, wherein what if negative q ni siya din ha instead na positive q. And also for B, if you want to solve this one, instead of having a discrete siya nga charges, sa letter B is continuous na siya because the charge is distributed over a line. Okay, so we have a 2L here. So similar gihapon ang pag-solve ani niya sa letter A. Pero magamit na kaani og integral because continuous charge distribution naman ang imuhang kaning line or lambda. Okay? Oh, kani siya oh. I think mo ni siya atong gisolve. Okay. Alright? Or maybe lahi siya. That is similar, but this time it's not a disk, but it's actually a loop. So circular loop na siya. So na-solve naman nato ni siya before. Pero diretso lang tani gamit sa formula sa E bitaw, katong automatic tani gamit. Sa kani is kung sa nato ang potential, once we have the potential, we can get the electric field. So the same gihapon siya nga process as what atong gigamit diri sa previous. So kana lang, you just have to do this on your own, on your free time, and then practice na gini siya. So more on practice gini electromagnetism, do the drill on make you analyze and understand the problem, and then gamiton ninyo ang mga mathematical tools nga ato ang pwede magamit to solve the problem. So this is like a summary. So we have seen so far that there are three fundamental quantities of electrostatics. We have the charge density rho, the electric field, and the potential. So magtugtuyok ko ni sila. So this image is taken from the book Griffiths. Okay, it's a very useful na siyang reference. So once na kay rho, we can actually get the electric field by having this formula, right? Simple na siya. Ano na siya nga formula sa coulombs. Or once you have the rho, you can get the potential by having this formula or kaning nga formula. And so on. Pwede pa balik. What if we have the potential? How do we get the rho? So kani itong gamiton. Right? Katong kaganina, rho, padulong potential, kani. Potential, so kung makuha sa electric field, we have this. But if you want the other way around, we have the electric field. How do we get the potential? We have this formula. So, tuyok na siya. Okay? So, si tawag ani, pyramiding scheme. Saan siya nga scheme. Okay, very useful. So, in general, the charge density rho and the electric field E do not have to be continuous. Now consider this example. We have a infinitesimal thin charge sheet with a surface charge sigma. So we can calculate for the electric field sa above and then electric field sa below, and we'll see if continuous ba ang iyang electric field when we try to evaluate this one at the interface. Continuous ba ang electric field at the interface? So the relation between the electric field above and below the sheet can be obtained using the Gauss's law. Okay, so consider a rectangular box. This would be our Gaussian surface. Consider a rectangular box of height epsilon and area A. The electric flux to the surface of the box in the limit as this epsilon, what this is epsilon, approaches 0 is equal to this. Okay, so this is not a sphere, that's a surface. Okay. Yung pagkaalan ni siya. Okay. Where E above and E below, perpendicular ni siya. So we are talking about perpendicular. Kani siya nga electric field. We're not talking about sa kani nga field. But later on, ito na siya. So using Gauss's law and a rectangular box shown as integration volume, we obtain this one. Okay, Gauss's law naman ni siya. So we have difference electric field because this is electric field, right? Total. E times A. Katong, let's recall the Q enclosed over epsilon naught equals E dot dA. Mama na siya. Siya ang formula. So we get this. So mag-cancel ang A. Cancel ang A. We are left with, so cancel na siya. We are left with this equation. Okay? So as you can see in this equation, ang E above ug E below is naa siya value, right? That would mean nga discontinuous ang imuhang electric field above and below at the interface, because if it is continuous unta, supposedly, if mo itong i-assume, then this would have been zero, but it's not. So discontinuous ang imong electric field at the interface of the sheet by this amount or value. So as what I've said kanina, katong tangential nga part, katong component sa imong electric field is actually zero. So we don't care about it, kay zero man siya, kani siya. Ay imong electric field sa dili nga component is actually zero. Okay, so na siya i-proof diha, but we'll just skip that one because yes, continuous na siya. And equal ang imuhang parallel ang tangential ni electric field below and above. So this boundary condition for the electric field can be combined into a single formula. Kani i-apply na diha ang katong duha ka component, the tangential and the katong perpendicular. So kani siya, where n hat is the unit vector perpendicular to the surface. Okay. So the electric potential is continuous across any boundary. So this is a direct result of the definition of V in terms of the line integral of E. So we have this definition. If the path shrinks, the line integral will approach to zero. Okay, so this will approach to zero and independent of whether E is continuous or discontinuous. Thus, we have V above and V below. So ang imong potential, on the other hand, is continuous, unlike the electric field. Okay, we'll just have to skip this one. Okay. So that would be the sum total sa atong discussion just for the electric potential lang na siya. So next week or next lesson nato would be the topics on work and energy. Sa may relationship ani niya sa work and energy. Actually related po din siya sa somehow sa ato ang potential.